Hello everyone, I am Dr. Biswajit Mahanti, Associate Professor, Department of Electronics and Communication Engineering, SR University, Warangal, Telangana, India. As per my previous lecture, I told we will prepare some video based on some numerical. Those will be helpful for your semester exams, GATE exam, or any kind of competitive exams. So today today's first numerical is assume that an op-amp has IB1 400 nanoampere and IB2 300 nanoampere. These are given. So determine the average bias current. And the offset current OS. Now the solutions. Average bias current, we know that average bias current formula is IB, that is average of IB1 plus IB2, IB1 by IB2. So now it's very simple. IB1 given 400 and IB2 given 300 nanoampere. So simply put 400 plus 300 into 10 to the power minus 9 ampere divided by 2. So that will give you 350 nanoampere. Now the offset current is given by offset current, they also told to find out the offset current. So the formula is the offset current is given by offset current IOS is equal to IB1 difference IB2. So IB1 is 400 only and this is 300 only. This is nanoampere. So 100 nanoampere. So this is the numerical. So hope you people understand. Now we will go for some other numerical one by one. These are very simple only. Now problem 2. An op-amp has a rise time of 0.7 microsecond. Now the question is determine the small signal or unity gain bandwidth. So now we know that here given that solution. What is given? The op-amp has a rise time of 0.7 microsecond. So rise time is equal to 0.7 microsecond. Now what is the relation between bandwidth and rise time? We know that bandwidth is equal to 0.35, this standard formula, 0.35 by rise time. So what we have? We have rise time. So 0.35 rise time, 0.7 microsecond. So 10 to the power minus 6 second. So that will give you 500 kilohertz. So that we got the bandwidth. So that was the question. Now problem number 3. Problem 3. What is problem 3? Now an op-amp has a unity gain bandwidth of 1.5 megahertz, that is given. Now for a signal of frequency 2 kilohertz, what is the open loop DC voltage gain? So what is given? Unity gain bandwidth of 1.5 megahertz. Unity gain bandwidth. Unity gain, so solution. What is given? Unity gain bandwidth of 1.5 megahertz, that is given. Now for a signal of frequency 2 kilohertz, so signal frequency, suppose this is f1, that is given 2 kilohertz. Now the question is, what is the open loop DC voltage gain? Open loop DC voltage gain. So there is a relation. My dear students, you please remember the open loop DC voltage gain, the formula, the open loop DC voltage gain A0 is equal to UGB, unity gain bandwidth, divided by F1, that is the signal frequency. Now here 1.5 into 10 to the power 6, because it was megahertz. So 1.5 into 10 to the power 6 hertz divided by 2 kilohertz. So that is equal to 2 into 10 to the power 3 hertz. So 2 into 10 to the power 3 hertz. So it will give you 750. This is 10 to the power 3. So it will give you, this is hertz cancel, 750, because gain is unitless, so 750. Now, so unity gain bandwidth, input bias voltage gone. Now we will come for slew rate. The problem number 3, problem number 4. So now problem number 4. Now assume that an op-amp 741, that is IC number. We may not write an op-amp 741 connected as a unit gain inverting amplifier. Is applied with an input voltage with an input change of 10 volt. So input change of 10 volt. This is most important word. Determine the time taken for the output to change by 10 volt. So you have to find the determine the time taken we have to find out to change 10 volt the output, that we have to find out. Now given that output voltage changed by 10 volt, so what is given? Solution. What is given? Now given that output voltage change is 10 volt and slew rate is given 0.5, because it is standard. You remember, if 741 IC is given, then we can say that slew rate is 0.5 microsecond, a volt per microsecond. So slew rate 0.5 volt per microsecond if 741 IC is given. It is standard. Now we know that 0.5 volt per microsecond. We know that slew rate what is slew rate? Slew rate is equal to output voltage change by time. So you know the slew rate, output voltage, so you will find out the time. So this is formula. What is formula? I am writing one more time. Slew rate, that is equal to output voltage change divided by time. Okay, so therefore, what is slew rate? Standard slew rate is 0.5 volt per microsecond, that is equal to 10 volt by time. So time is equal to 10 volt by 0.5 volt per microsecond. So if we calculate it, it will give you 20 microsecond. It's most important. Okay, so problem 4 finished. Now problem 5. assuming that slew rate for 741 is 0.5 volt per microsecond. What is the maximum undistorted sine wave that can be obtained for a 12 volt peak, B 2 volt peak is the question. So what is given is that slew rate 0.5 volt per microsecond and peak voltages, first one 12 volt, then 2 volt. So let us start the answer. Now given that slew rate 0.5 volt per microsecond. So now question number A, the sine wave of 12 volt peak, that is given, the first one, sine wave of 12 volt peak. Now there is a relation slew rate and sinusoidal voltage like this. Slew rate so suppose we will define first slew rate for your better understanding. What is slew rate? Slew rate is equal to output voltage change, as I mentioned, divided by time. So that means dVc dt, that makes the output voltage. So rate of change of voltage, maximum rate of change of voltage. dVc means output voltage in time in t. So ddt of Vc, we can say that, or I max by C. So we will remember this one, dVc dt. Now as you mentioned, the sine wave, for sine wave, that is, suppose V0 is equal to Vm sin omega t, where Vm is the peak voltage, omega is the frequency, t is the time. So that is the case. Now we have to find out dVc dt or dV dt, that is rate of change of output voltage. So now the rate of change of output voltage, that is equal to dV0 dt. we can write dV. dV0 dt output voltage will be very clear. dV0 dt. So dV0 dt. So dV0 dt, if V0 is equal to this, so Vm cos, it should be Vm sin integration a differential, it should be cos omega t into omega. So ultimately what we get, dV0 dt is equal to Vm omega into cos of omega t. Now you will find out dV0 dt max. dV0 dt max. So Vm into omega. So cos t max, cos omega t max is 1 into 1, because cos omega t, the maximum value is, cos omega t maximum value is 1. So this one is Vm omega. So now we can write Vm into omega means twice pi f, 2 pi f, twice pi f. So dV0 dt max is equal to Vm into 2 pi f. So that is slew rate, SR. dV0 dt means slew rate. So slew rate is equal to twice pi f into Vm volt per second. Why? Because dV0 dt, rate of change of voltage, the voltage change by time, so volt per second. So this is very important expression. Slew rate is equal to twice pi f into peak voltage. That is one more formula you please remember, my dear student. The full power bandwidth, full power bandwidth, FPB. So FPB is equal to slew rate divided by twice pi V set, where V set is the saturation voltage for op-amp channel. V set is the saturation voltage for an op-amp. So these are the important formula. Now we will come to the numerical. What is given? Slew rate is given, sine wave peak voltage is given. So SR is given and peak voltage Vm is given here. So what is the formula? So SR is equal to twice pi f into Vm. This is volt per second. Okay, no problem. Twice pi f Vm. Now what is slew rate? Slew rate is 0.5 given. Slew rate is, so now for first numerical. Okay, slew rate is how much? So slew rate is 0.5 microsecond, that is twice pi f max I am writing, into Vm is 12 volt. 12 volt. So f max is equal to, what we get is 0.5 microsecond divided by 2 pi into 12 volt. 0.5 volt per microsecond. 0.5 volt per microsecond. So if we calculate all those parts, it will give you all the calculations. So f max will come out 6.63 kilohertz. Now question number B. Here sine wave, for sine wave of 2 volt peak. So here F max from this formula, F max is equal to SR slew rate by twice pi into Vm. Slew rate 0.5 volt per microsecond divided by twice pi into 2 volt. So that will give you 39.8 kilohertz. So simple. So this formula we have to remember. Now we'll go for problem number 6, I think. This is problem number 5. Now problem number 6. Problem number 6. Now problem number 6, we will write the problem number 6. Now again we are dealing with IC 741 is used as an inverting amplifier with a gain of 100. The voltage gain versus frequency characteristics is flat up to how much? 10 kilohertz. So up to 10 kilohertz is flat. Determine the maximum max, maximum peak to peak input signal. We are finding input signal amplitude, peak to peak input signal that can be applied that can be applied without any distortion to the output. So we are finding the limitation of the input voltage swing, peak to peak input voltage. So input voltage swing, maximum input voltage swing we can apply. Okay, so view parameters is given, the flat characteristics up to 10 kilohertz, voltage gain of 10, 100. So all these parameters are given. So IC 741 is mentioned. So in this case we can use slew rate 0.5 volt per microsecond in used and an inverting op amp with gain is given 100. The voltage gain versus frequency like this is voltage gain versus frequency is like that, it should be constant up to, suppose this is 10 kilohertz. After that it may fall like this. Okay, so voltage gain versus frequency characteristic is flat up to 10 kilohertz. So this point suppose 10 kilohertz. Determine the maximum peak to peak input signal that can be applied without any distortion to the output. So you have to find out input peak to peak voltage. So we know the formula, solution. What we know the solution? Slew rate is equal to twice pi F max or F whatever into Vm, the peak voltage. Now Vm, that is called maximum peak or max, we can tell that, not peak, we can tell the max. Max is equal to what will happen? Slew rate by twice pi F. What is slew rate? 0.5 volt per microsecond divided by 2 pi into frequency. Frequency how much given? Frequency given 10 kilohertz. Because up to 10 kilohertz no change. Up to 10 kilohertz flat. So 0.5 volt per microsecond divided by 2 pi into 10 into 10 to the power 3 hertz, and divided by microsecond. So we may write 0.5 volt by twice pi 10 into 10 to the power 3 hertz into microsecond will come down, so 10 to the power minus 6 second. So if we calculate all the things, it will come out at 7.96 volt. So Vm, input voltage maximum, we can handle is 7.96 volt. So this is most important. So this is problem number 6. So my dear students, you follow all the numericals. You practice at your home. Now one more problem, slew rate. So this is problem 6, problem 7. Problem 7 on slew rate. Problem number 7. The output voltage of an op-amp circuit changes by 20 volt. So output voltage change is given here. The output voltage of a op-amp circuit changes by 20 volt. So output voltage change of op-amp is given 20 volt. In how much time? In 4 microseconds. So many things given. What is its slew rate? It's very simple. What is a slew rate? So solution. What we know that? We know that slew rate is equal to output voltage change divided by time. So output voltage change how much? 20 volt. So write 20 volt divided time how much? 4 microsecond. So 5 volt per microsecond. So this is the answer. So answer is slew rate, that is equal to dV0 dt, which is nothing but 5 volt per microsecond. So we have solved many numericals. Problem 7. So 7 problem we finished. Now you practice all those numericals. This 4. You take, I wrote the questions, so you write down the question first, then pause the video and you try to solve the numerical, and after that you just follow the video. So that will be good for you. Next we will go for few more numericals. I am thinking for different videos. So first you solve these numericals. Okay, then we'll go for some CMRR and inverting, non-inverting, all those. This means unit 2. We'll go for unit 2. Okay. So till then, stay tuned with my YouTube channel, and we'll come with more exciting videos. So definitely the next video will be with the remaining numericals. So till then, Bye bye, see you again. Thank you. And one more thing, if you like my channel, YouTube channel, so don't forget to like and subscribe, and also share with your friends, those actually need all these videos. So thank you.